So the aerospace industry is always one with big news. We hear a lot about SpaceX, Blue Origin, rockets going up, things going to Mars, all kinds of great stories happening. But one of the cool stories that's happening as well is from a company called Leap71. And it's sort of a new company. They've been around for a few years. We've talked about them in the past. But one of the recent publications or announcements they did is their new engine designs. Now, just to give you a little background, Leap is actually a company that specializes in 3D printing next generation rocket engines, specifically engine designs that we could not do previously. One of the concepts that they create is called the aerospike engine, a design that's actually been around since roughly the 50s, but was essentially too difficult to manufacture and test. So we've known about the idea, but we could just not actually make it until Leap71 comes along. In their recent announcement, they have test fired 2 of their new engines, and they're about this big in terms of size, designed for like just testing the shape and seeing if their calculations are correct, to be scaled up afterwards. And one of the cool things about these engines and the creation of them is not only are they fully 3D printed, but they're also designed by software. Meaning that instead of sitting down and coming up with an idea and figuring out how to shape it and create it, they start with just the constraints and tell the software, this is your limitations, design the best solution. And from that, they're able to create these next generation designs. Now, in the recent test, they actually took 2 different designs, or maybe a better way of saying is they allowed the system to create 2 new designs and fabricate them. And what's really cool is the fact that they did this all within 3 weeks. From the moment they came up with the concept of doing this to the actual ready-to-go product took only 3 weeks for it to design it and then to 3D print it. A major breakthrough in terms of aerospace manufacturing. That's just simply not done. It's just too fast. But because of the technology and because of the software figuring out what is the best design, these engines were created. And you can actually see the tests anytime that you want. They publish a lot of their information and the results online. It's amazing to watch. And in these cases, the 2 engines, they produced around 20 kilonewtons of thrust, which is about 5,000 pounds from an engine about this size. Now that they have validated their results, and I think they ended up being about 93% fuel efficient, using a mixture of methane fuel, which is much cleaner and is sort of the new rocket fuel of today. Now, what's also really interesting is that these models represent the test runs and roughly 10% of the target thrust. So over 2026, now that they've actually developed out the primary designs and kind of done the validations, they'll be moving on to actually the full-scale models, which will just involve larger printers. Really, really cool stuff. One of the comments they also point out too is that methane, although a great new rocket fuel, and what most companies are switching to in terms of its cleanliness and availability, is also its difficulty in computer modeling and how to use it as a propellant. And their proprietary software that Leap71 developed is part of the process. It's not only modeling the explosive potential of the fuel and the way it behaves, but combining that with the perfect shape to channel and funnel that. And even when you look at the engines, you can actually see that they can do some of that, primary bell shape, which we're kind of used to seeing, into the much more exotic shapes. And again, only done in 3 weeks. That is incredibly advanced and powerful in terms of iteration and improving performance. Leap also does something a little bit different than most in the fact that they use copper alloys, which are very, very good for rocket engines in concept, but are notoriously difficult to manufacture, again, until 3D printing is used. So not only is the technology making it possible to do complex shapes that we couldn't do before, but also allowing us to shape particular materials that we could not shape with very easily. So Leap71 really represents a great step and demonstration of the power of the technology, because it's making materials more available, shapes more available, and actually modeling those shapes to exactly what's happening within the explosive nature of rocket propulsion. They even point out, like in 2026, not only will they be scaling up to their larger size, 200 kilonewtons of thrust, they're also targeting 2,000 kilonewtons of thrust, much more towards the actual practical applications. But the ability to just prototype the small one and then validate and then go do the big one is really awesome, especially again given 3 weeks of timeline. So another thing about Leap is that they're a young company, probably less than 5 years old. I remember reading an article about the whole aerospike design that was previously difficult, and then this company was just getting funded to change that because of 3D printing. So you can see that ability to enter into these new markets just because of the technology now exists, the things that it can make for us based on whatever we design. So as always, let us know if we can help you kind of walk into this technology yourself. Maybe not being in the rocket engine side of things, but maybe you want to see how 3D printing can benefit your business, or can allow you to express your own creativity, and maybe you're a hobbyist, whatever the case may be. We offer courses specifically in 3D printing to help folks use this technology for the betterment of their own operations, but also our world, because it really does open the door for new things that we previously could just never make. As always, thanks for watching. Let us know how we can help. You can always check out some of our links and sign up for classes whenever you like. We'll see you.